All right, I think now I'm recording. All right. All right, so let's start with the section 5.2. So this is so exercise 5. So this is about so this is section 5.1 and 5.2. Right, so it's about probability rules. So let me just remind you of the rules, okay? Before answering the problems, let me just remind you the main rules of the formulas that you need to know, right? To answer this exercise number 5. So just to remind you, so we have two probability rules, right? So first we have multiplication rule. So one multiplication rule. So if you have two events, A and B, so there is a first case when A and B are two independent events. So case 1, A and B are independent events. So then probability of A and B, it's actually probability of A times probability of B. And then the second case, so case number 2, this is when A and B are dependent. So if A and B are dependent, so then dependent events, of course, then P probability of A and B, that's probability of A times probability of B given A. And the other rule, that's the second rule, is the addition rule. So then you the word or becomes a plus, right? So this is the addition rule. So you have two events, A and B, then probability of A or B. That's probability of A plus probability of B minus probability of A and B. All right, now let's do the first example. I mean, the exercise 5. So example 1 or exercise 1 or example 1. So let's see. So you roll two fair dice, a white one and a red one. Okay, and so we roll two dice. Okay. A white one. I don't know if you have the review sheet in front of you guys, but it's on CUNY Blackboard. I don't think I can like share the review sheet with you, right? But yeah, it's on CUNY Blackboard. Okay, a white one and a red one. Okay, so we have two dice. One is white and the other one is red. And so the first question is to find. You want to find the probability of to get, let's say, 5 or 6 on the white die, and odd number, an odd number on the red one. Okay, so here, guys, there are like two events. The two events are separated by the word and. So the event A, this is the event where you get 5 or 6 on the white die, getting 5 or 6 on the white die. Okay. And the event B, this is where you get an odd number on the red. Okay, so what's probability of A? We need to find probability of A, right? And actually, so this is A, so this is 5 or 6 on the white die. That's the event A. And to get odd number on the red, that's the event B. So we need to find probability of A and B. And B. Okay. So the question is, are A and B independent or dependent events, right? Because this is A and B, right? So then A and B, as we said, there are like two cases, right? A and B, there are two cases. There's a case where the two events are independent. There is no relation between the two events. And the second case where the two events are dependent. So it depends on whether your events are independent or not. Okay. Now the question is, so in our example, you roll 2 dice, right? And then like the first event, you get some number on the white one, and the second event is you get another number on this on the red one. So are the two events, are they independent? So when you roll 2 dice, right? Getting a number on the first and getting another number on the second, I mean, there are no relation between the two events, right? There is no, they are independent, right? Because there is no connection between the two dice, I mean, right? So they are independent. So in this case, the A and B are independent. So A and B are independent. So if they are independent, then we need to apply the first formula right here. So, right, the P of A, probability of A times probability of B. So that will be equal to probability of A
to 30
times, yes, probability of B. Now, so we need to compute probability of A, and we need to find the probability of B. So what's probability of A? Probability of A, so A, again, it's the event where you get 5 or 6 on the white die, right? So what's probability to get 5 or 6 on the white die? I mean, on the die, of course, there's numbers are from 1 to 6. So getting 5 or 6 on the white die is what will be the probability of that? So 5 or 6, that's 2 numbers, right? Out of 6 numbers, right? So any guess what will be the probability of A here getting 5 or 6 on the white die?
Is it 1 over 5?
Nope.
Is it
So to
2
get
over
one number, say it again, sorry.
2 over 6?
2 over 6, right? I mean, the probability to get a number, let's say the number 5, just number 5, okay? That'll be 1 out of 6, right? Now, it's not just number 5.
But
now,
that's why I said you said they are independent, so I figure it's one letter for each number, and you only see 5 one time on the die.
no, but the A and B are independent. Now I'm talking about just A. A is getting 5 or 6. The independent events are A and B, right? I'm talking about, so here I'm just talking about the event A. So here, when I talk about the event A, so there's no notion of independent or dependent, right? It's just the event A here, right? So if it's just the event A, and here we want to get either 5 or 6, so that's like 2 chances out of 6, right? So either you get number 5 or you get the number 6. So to get 5, that's 1 chance out of 6, and to get 6, that's 1 chance out of 6. So 5 or 6, right? So that's 2 chances out of 6. So probability of A to get 5 or 6, that's 2 out of 6. Does this make sense? Okay, let me see the chat. Just make sure. Okay. All right. So because to get 5, that's 1 chance out of 6, and to get 6 it's also 1 chance, right? So that's 2 chances out of 6. Now, what about probability of B? to get the odd number on the second die.
So would that be 3/6?
Yeah, that's 3/6 because we have three odd numbers like 1 or 3 or 5, right? So that's 3 chances, right? So that's 3/6. So I got my P of A, that's 2/6, and I got my P of B, that's 3/6. Now, so to answer the question, so the answer here, probability of A and B So probability of A, we said it's 2/6 times, right? This is a multiplication, right? This is multiplication times probability of B, which is just 3/6. So that will be, so here we multiply fractions. I mean, you can divide the fractions if you want, but you can also multiply the fractions. You can just multiply straight across. So that's like 2 times 3. That would be 6. And in the denominator in the bottom, that's 6 times 6. That's 36. So just divide. You just divide the 6 by 36. So that's just equal to 1/6, which is 0.16. So this is 0.16 converted into percentage. Of course, that's 60%. Okay. Please don't be shy, guys. If you have questions, let me know. All right, so that's for number 1. The B. Find. So find the probability of, so capital P of odd number on the white die and on the white die, and then oops. And 5 or 6 on the red one. So 5 or 6 on the red. Okay. So we have again 2 events. The first event is when you get an odd number on the white die. That's your event A, right? Let's call this is the event A, right? And then the second event is to get 5 or 6. So that would be my second event. So this is the event B. This is B. Again, it's just the same, the same probabilities, right? So of course, A and B here are independent. There's no connection between the 2 events. So this is just the probability of A times probability of B. Okay, because again, A and B are independent. A and B are independent. So, all right. So again, to get the probability to get the odd number on the white, so we have 3 chances out of 6. So that's 3/6 times B, probability of B, 5 or 6 on the red. It doesn't really matter. That's the dice, red or white, right? So it's 5/6. So 5 or 6. So again, that's 2 out of 6. So it's just the same answer. So that's 60%. Okay. I mean, it's the same thing, because it doesn't matter if you get the odd number on the red or you get the red number on the white, the probability is the same, right? It's still 3/6. Any questions so far, guys? Okay, no questions. All right, so for C, let's see, what's C? So here's for C. So it's in C set, it says you need to find the probability of capital P of, so 5 or 6 on the white. Oh yes, on the white. And so on the white die, you want to get 5 or 6, and on the red, what's the event on the red? It's 5 or 6, right? The same thing. So 5 or 6. on the red. Again, rolling the dice here. It's just the independent events. So
It
let's
will
call
be
the first.
2/6 for both.
Yes, that's just
Dice.
2/6. Yeah, for both. Yes.
Okay,
So yeah, absolutely. Yeah, Yanni. So this is A, this is B. Again, then the events are independent. You know, so this is probability of A times. So because of N, so it's times probability of B, 5 or 6. So that's 2 out of 6 times. And to get 5 or 6 on the red, it doesn't matter red or white. So it's just 2 or 6. Right, so we multiply straight across here, multiplication of fractions. So 2 times 2, that would be 4 in the top, and in the denominator, that's 6/6. So that's just 4, over 36, and that will be equal to 0.11. So that's 11%. Okay. Let me see if there's any question in the chat. Okay, no questions in the chat. Oh, sorry. All right. All right. So that's for the first example or first exercise. Second exercise. So let's do the section. Let's do the section of 5.2, guys. 5.1, 5.2, as I said, because that's what we discussed last week. And then I will start from. And then we can move to the section 2. All right, so example number 2. So let's see. So the dean here in the college found that 12% of the female students are majoring in computer science. So we have. I probably need to mute someone, I guess. Sorry about that. Let's see. Okay. All right. So we have 12%. So let me just write down the numbers. So it says 12% of the female students are actually majoring in computer science, or majoring in computer science, right? And then it says 64% of the students are actually female, right? 64% of the students are female. All right, so we need to compute, or we need to find what's the probability that the student chosen at random, right? So the random student will be a female majoring in computer science. So female majoring in computer science. So we have like 2 events here. First event is being a female, right? The second event is majoring in computer science, right? So let's say F, that's being a female, right? And then let's say S, that's majoring in computer science. Okay, computer science. So we want to find probability of, so we need to read carefully the question, guys. It says, what's the probability that a random student will be a female majoring in computer science? So it's a female and majoring in computer science, right? At the same time, female majoring in computer science. So this is the probability of F, female, and, right, majoring in computer science, right? So it's not female or majoring in computer science. So this is female and majoring in computer science, right? All right. So in this case, so here, because it's and, right? So we need to apply multiplication rule. Now the question, of course, is, are the 2 events here, are they independent or dependent? So we need to keep in mind, guys. So first event here is being a female, right? And the second event is actually majoring in computer science. Whether you're measuring computer science or not, okay, it actually, of course, depends on if you are a female or a male, right? The percentage varies, right? We have different percentages for a female and different and male, right? So the two events here actually are dependent, okay, because it depends if the percentage of students measuring computer science depends on whether the student is a female or a male, right? So here we have actually two dependent. This is two dependent events. So here the events are dependent. Dependent because measuring in computer science depends on, measuring, so measuring in computer science depends on whether the student is whether the student is a male or female, right? The percentage depends on if the student is a male or female. So we are supposed to apply the second second formula, right? When the two events are dependent. So that will be this. The second formula right here. A and B are dependent. So that's the probability of the first event times the probability of the second event given the first. So let's just apply the same formula here. So here that will be probability of the first event, probability of F, times probability of the second event given the first. The second event, which is measuring in computer science, given that the student is a female. Given that the student is a female. So this is, of course, given that the student is a female. All right, so let's see. What's the probability of F? Probability of being a female. So how many students, what's the percentage of female students? Sorry, say it again, sorry.
12%.
No. So
64.
probability of 64. We are looking for the probability of being a female. So that's the percentage of female students, right? Probability of F, that's the percentage of female students. So 64% of students are female. So that's the percentage of female students. So probability of F being female, a female student, that's a 64%. So here it's 64% times. Now, probability of measuring in science, given that the student is a female. So see here, guys, it says 12% of the female students. So we know that the student is a female here. So 12% of female students are measuring in computer science. So given that the student is a female, we know that 12% actually of the female students are measuring in computer science, right? So here, this 12%, this is the probability that probability of measuring in computer science, given that the student is a female. We know that the student is a female, right? That's 12% of the female students. So the sample here is represented by female students. So we just forget about the male students, right? So the sample is given only by female students here. So the probability of measuring in computer science, given that the student is a female, that's a 12%. So that's times the 12%. Okay.
Is it going to be 0.76 or we times by 100?
No, don't time. So, well, yeah, of course, later, yeah. You multiply first and then
If you change it to multiply initially, like if you take the percentage now and you make it 0.64 times 0.12, then you have to multiply by 100 to make it back.
Yeah, because that's what I have. I did 12 over 100, 0.12, 64 over 100, 0.64. I did 12. I did 0.12 plus 0.64. I got 0.76.
Yeah, and then you convert So then you multiply by 100 to convert into a percentage. So yeah, you're right, Kayla. I mean, so it's you divide by 100. So it's 0.64 times, and 12 you divide by 100, so that's 0.12. That's 0. So as you said, that's 0.07, let's say 6. But then, as Yanin said, we need to convert into percentage, so we need to multiply by 100. So that's a 7.6%.
Yeah.
Okay.
Oh, you got 7.6? Yeah, I have 76. Maybe I didn't put my points in. Right.
No, you multiply, it's 0.07. I think probably you missed the 0.
Yeah, 0.64.
Yeah, you missed that.
Okay, here we go, 0.76 times
Yeah.
100.
Yeah, 100, that's 7.6.
It's still coming out as 7.6.
Yeah. I think you missed the 0 the first time.
Oh, okay.
If it's 0.76, then yeah, so that would be 76%. But the 0.076, that's 7.6. Yeah. All right, guys. Let me just check the chat. Oh, I see there's a couple of questions in the chat. Let me see. Yanin, yes. Yeah, I don't know what's the 18.75%.
No,
We're
it's
talking about
initially
the
like just dividing the 12% over the 64, and then I realized the formula stops, and then
okay.
that's where the second one,
Okay.
0.6 came
Okay.
in.
I'm still not getting it right in my calculator.
You didn't get the 7.6?
No, and I'm doing it. I just redid it. I did 0.64 times
0.12
0.64
times
Wow.
0.12.
Yeah.
Yeah, that's 0.07.
0.12. Yeah. I got 0.76.
It's not 0.76. It's 0.076.
Yeah. Oh, because I did. Oh, all right. Okay, I see it. Okay. All right.
All right, guys. Let's move to the example 3. So we can finish this with this section 5. It's chapter 5. So this is example 3. All right. I mean, I think we discussed this like in details last week, right? With the table, having a table, etc. So we have again, the table is in the review sheet. I won't really, I won't write down the numbers again. So the numbers again is on the review sheet. So we have this table. The Committee on Student Life did the survey. So we have of 417 students. So we have a survey. This is a survey of 417 students regarding satisfaction with the student government and the class standing. So we have the results, right? Now, so we need to find the probability that the student selected at random is. So first, it says satisfied, right? So A, we need to find the probability that the random student is satisfied. So, so here, probability that the student is satisfied, right? So the event here, of course, is the student being satisfied, right? Again, to compute the probability, you need to first find the frequency of the event, the frequency of the occurrence of the event, right? How many, we're talking about satisfied students. So how many satisfied students do we have in total, right? That's what we have to find, right? So if you take a look to the table, guys, and
It was 180.
180, thank you, Yanin. So that's 180. That's the total number of satisfied students. Right? Over the size of the sample, in total we have 417 students. So the size of the sample, so this is the size.
Oh, so that I did right. That's 43%.
Yeah, that's right. So just let me just finish the size of the sample. So yes, absolutely, as you said. So this 180, if if you divide 180 over 417, so that will be equal to 0.443, and converts to into percentage, that's 43% times 100%, that's 43. All right. Let me know, guys, if I'm going fast. Okay, I don't.
That's the same steps that we just did before, right?
Yep, the same steps
Okay.
that we did before. Yeah.
What I did wrong is I was adding the 0 point, what we were just doing, I had questions about. I was adding, I didn't multiply it.
You're talking about example number 2.
Yep,
Well,
That's
that's
why I
the
did it
thing.
wrong.
That's you need to know. I mean, if you see the word and,
Mhm.
and
I don't know
it
why I did
means,
that.
yeah, you need to multiply.
Okay.
With the word and, yeah. In B, guys, it says satisfied given that the student is a senior. So in B, it says probably that, so satisfied given the student is a senior. So we know for a fact that the student is a senior, right? So then the size of the sample is given by senior students.
So we count all the seniors, right?
Yeah,
Which
we
is
count all the senior,
115.
which is 115. Thank you, very good. So
And
that's
satisfied seniors is 65.
satisfied senior 65. Absolutely. So that's
Okay.
65 in the top. So in the bottom, that's the number of senior students, and this is satisfied senior students. Right. So that's of course 65 over 115. That will be equal to 0.56.
And
So
you
that's-
guys did the 180 over 100 and got 1.8, right?
You are talking about which one? 180. Sorry.
Right there
Say it
for
again.
satisfied. For satisfied, is that how you got the 0.43? You did 180 over 100?
Oh, yeah. 180 over 417.
Oh, I'm sorry, 180, okay.
417, that's the total number of students. That's the size of the sample.
65.
That's the total number of students.
Okay.
But the thing is, with if you see the word given, like in a B, there's the word given, the student is a senior. So when you see the word given, then you need to change. You change the size of the sample. So it's not the same denominator. It's not the same bottom. So you need to change the bottom here. Whenever you see like in table, so we have like a table, and the question is says like given that something, right? Then you need to change the denominator, the size, the sample. So in A, the sample was all the students. In B, the sample is given only by senior students, not all the students, but just senior students. All right, so for C, it says probability that the student is junior or, okay, so now there's this word or, right? Junior or not satisfied. So with the word or, then we need to apply our formula. Remember, for or, it becomes a plus. So right here, where is it? Here. So if you have a or, see the word or, right? So then you need to apply this formula right here, this one, okay? So then we're gonna have like 3 different steps where you find the P of A, P of B, and then P of A and B. So for or, we have or, junior or not satisfied. So that would be probability of the first event, probability of being a junior, because or, so now we have a plus because of or. Then probability of the second event, which is not satisfied, minus, all right, this is it's a subtraction here, minus probability of junior and not satisfied. So minus probability that the student is a junior and not satisfied. All right, so first we need to find the probability of a junior. So this is like the first step. This is step one, junior. Well, probability that student is a junior. Again, it's count how many junior students. As you can see in the table, the total number of junior students is 98. Thank you. So it's 98 over our usual denominator, which is the size of the sample, which is 417 students, plus not satisfied. So in total, we have 71 not satisfied students. So that's 71 over 417 minus, right? This is a minus right here, junior and not satisfied. So it's junior and not satisfied at the same time. How many junior not satisfied students?
98.
98. Nope. 98.
Oh.
That's the total. No, 98. That's the total number of junior students. I'm asking about junior and not satisfied at the
It's
same
23.
time. 23. You see the 23? That's the number of junior not satisfied. 98. That's the total number of junior. So, and the junior, of course, it can be not satisfied, neutral, or satisfied. But junior and not satisfied, that's 23 over the same, size of the sample, right? It's 417. So, yeah. Now 98 over 417, that's actually equal to 0.23. All right. 71 over 417, that's actually equal to 0.17 minus, right, 23 over 417, so that would be equal to 0.05. Right? So if you do 0.23 plus 0.17, this is actually 0.4 minus 0.05. So this is like 0.40 minus 0.05. So that will be 0.35. And so this is for 35%. So my advice for you guys, for sure, you're gonna have similar problem in the test. I mean, there's no way you cannot have some similar problem. So when you see or, please apply this formula right here. Probability of A plus probability of B minus probability of A and B. Okay, so write down the formula first, okay? Because write down the formula first, right? And then for each, you need to find the probability of each term, okay? Any questions so far? Let me see the chat. Okay, I don't see any question in the chat. Yeah.
And then we multiply those that you got the 0.23, 0.7, 0.5. Right? Oh, no, it's or. It's okay. It's or. It's addition.
No, this is or. No, this
Yep,
is
it's
or.
or.
This is addition. Yeah.
Okay.
Yeah. Well, for D. So B, C, D. Probability of, indeed it says neutral. So neutral and, okay, so here it's the word and, freshman. So the question is, how many neutral and freshmen and at the same time and freshman students? Any guess how many neutral freshmen?
There is 61.
Yep, 61. That's the answer. And divided, of course, by the size of the sample, we have 417 students, right? That's the size of the sample. So it's just 61 over 417. Okay. This is, again, this is the number of neutral and freshmen. So yeah, so it's just 61 over 417, which is actually equal to 0.14. So 0.14, which is of course 14%. All right. E, neutral, given that the student is a freshman. So as I said, you need to keep in mind, if you see the word given, you have a table of numbers, you see the word given. So then the denominator, it's not the size of the sample. So here, so E, so it says neutral, probability that the student is neutral, given that the student is a freshman. So the denominator here, guys, it's not given by all the students. It's just given by freshmen, right? Freshman students, right? Because given that you know that the student is a freshman, right? So your sample is just given by the freshman students. So the denominator would be the number, the total number of freshmen, right? Which is, any guess what would be the total number of freshmen?
The neutral for freshmen?
No, yeah,
All-
freshmen. Just
All the
freshmen.
freshmen is 101. All the
Yeah,
freshmen.
yeah,
Neutral
all
is
freshmen.
61.
Yeah, all freshmen, that's 101. That's the number of freshmen. Now the top, that's neutral freshman, right? So neutral freshman, we have 61. So this is neutral freshman. So
61%?
anyways, yeah. So just again, keep in mind, guys, this is given, then you need to think about the denominator, okay? So you need to change the sample, size of the sample. It's not 417. It's not all the students, right? It's just, in this case, it's just freshman students. So yes, yeah, as you said, so that would be equal. So that's a 0 point, actually 0.6. So 0. So that's 60%.
I did that for the actually a D. That's how you just did for letter E. I did it for D, and I see where I got confused.
Yeah,
I didn't count the
yeah.
whole entire school for letter D.
Letter D. Yeah. Yeah, I know it's confusing. That's why. But again, that's yeah. Well, like for F, it says again, it's given senior. So F. So it says probability of senior, given that the student is satisfied. Oh, sorry, senior. So here, let's say SE, given that the student is satisfied. So the denominator is given by the satisfied students, right? Here, the denominator 101, that's the freshman, right? So here satisfied, so the denominator would be given by all the satisfied students, which is 180, right? In total, we have 180 satisfied students. So this is 180 here. And in the top, that's the number of senior satisfied students, right? So senior satisfied students, we have 65. So this is 65. This is the number of senior satisfied students. So yeah, so then that's 65 over 180, which is actually 0.3, I think, 0.36, yes, 0.36, which is 36%. So given something, right, then the denominator would be like the total number of the assumption, right? So for example, here, given that the student is satisfied, so then the denominator is the number of satisfied students. Given that the student is a freshman, so the denominator, the bottom, that's the number of freshman students. Okay. Any Any questions so far? Let me see. Okay. All right, guys. So that's for, well, already just one hour for just one chapter 5.
What was answer B, Professor? I'm sorry, I got the rest.
B?
Of it.
B
Yeah,
for satisfied given the senior.
yeah.
Yeah, it's 56%. So you see here for B, it says given senior. So the denominator, the bottom, that's given by the senior students. We have 115 senior students.
Okay. So basically, when it's given, whatever they're asking about, you're gonna add that total up, and then the one that they're specifying, that one goes on the top.
Yep. Yep.
Okay. All right.
Mhm.
All right. You know, I had the nerve to mess up the classes, right? When I on section 2.1.
No,
I said, are you
but-
serious?
no, but,
I'm messing this shit up. I mean, stuff up.
So again, my advice for you guys, I mean, because you're free to have like a, for a formula sheet, just write down an example, like just like, I guess like this example, for each case, like when you have and, or when you have given that, or you have or, I would write it down like an example for each case, and all
So
right.
like
So
F, E, D, and C, they're like the same, right? Because it's like junior or not satisfied. Oh, no. C is
Female.
different. So D,
well,
E-
D and well, it's it's about neutral and female, and neutral and female students, but of course we have like different probabilities, right? In D it says neutral and female, but in E it says like neutral given that the student is female, right?
yeah.
So yeah, they are different. Yeah. All right, guys.
Professor, and there's no possibility of having negative answers on this exercise, right?
No. Of course,
Right.
it has to be
There has
positive.
to be
Everything has to be
something.
positive. Yeah.
Right.
Because the probability of the answer, it has to be a number, positive number between 0 and 1. So yeah.
The reason I
Well-
asked is because let's say you are subtracting
No,
the
no.
numbers.
that's-
Go
yeah,
ahead.
Yeah. But what you subtract, it's supposed
Mhm.
to belong like to one of the sets. So it has to be less than the other numbers.
Okay.
Because of that's because of the formula. Yeah, it has to be less than the other numbers. Yeah. So the answer is always positive. And actually the answer is always between 0 and 1, or 0% and 100%. All right, so we need to move to the next chapter, guys. We don't have time. It's like just 30 minutes. Any specific requests, or I can probably just move to the or to go back to the chapter 2.
Can we go to chapter 2?
Yeah. All right.
Because I was trying to do it.
Yeah, we can do that. Let me just check the chat again, make sure that all right.
Because I'm good all the way
Right, so-
until after I do the width. Then I started getting confused. I thought that I put the highest number. or the-
Okay, let me go over. So let me go over the first exercise. So this is exercise 1. Just to remind you, very quickly how to do the frequency table, etc. So this is about chapter 2, of course. This is section 2.1, chapter 2, section 2.1. All right, the frequency table, so we need frequency table. It says frequency table with 5 classes, right? Just be careful about the number of classes. So here we need 5 classes, right? So first you need to subtract. So largest value or data value, largest data value minus the smallest one over, of course, the number of classes. Just be careful here. We divide by the number of classes. So like in our example, the largest data value, if I'm not mistaken, is, so
35.
this is the list 32?
32.
Oh, I'm sorry,
32.
32.
Yeah.
32, yeah.
And
Thank
then
you. And the smallest would be
3.
3, I guess, right? See,
Yes.
over number of classes we need, we need 5 classes, so over 5, right? So we subtract first 32 minus the, that'll be 25. That's 20, sorry, that would be 29, sorry, over 5. And 29 over 5, that's 5 point, I think 8, right? And so then the width would be the next, the width has to be the next higher integer. So next integer, of course, I mean integer, I mean whole number, right? Next whole number, well, integer, it's just right here, whole number. So that will be 6, right? That's be 6 here. That will be equal to 6. So that will be the width. Right. So now we need to find the classes boundaries. But before classes boundaries, we need to find classes limits, right? Even if the question doesn't say like classes limits, you need to first you need to find the classes limits, right? Because that's how we find the classes boundaries. So I would say, like as a step number 3, we need to find the classes limits, even if it doesn't say in the problem, it doesn't ask you for the classes limits, but you need to find the classes limits first before the classes boundaries. So classes limits. Well, of course, you have the lower bound or lower limit, and upper limit. So so we need the 5 classes, right? So 1, 1, 2, 3, 4, and then 5. So this is the first class, second class, third, fourth, and fifth. All right, so the lower limit of the first class, that will be the smallest data value. So the smallest number here is 3. So that will be the lower limit of my first class, right? Now, for the lower limit of the second class, we add the width, right? That's 3 plus 6, right? So we're gonna have plus 6 here, plus 6, plus 6, plus 6. So that's 3 plus 6, that would be 9. 9 plus 6, that's 15, plus 6, 21, plus 6 is 27. All right. Now for the upper limit, so you need to subtract 1 from the lower limit of the second class, right? So here this is 9, so you subtract 1, so the upper limit of the first class would be 8. All right, but then next upper limits, just to add 6 each time. So at 8 plus 6, that's 14, plus 6, that's 20, plus 6, that's 26, plus 6, that would be 32. Okay, so those are my classes limits. Any questions so far? I need to check the
I did
chat.
it backwards. That's why I didn't do it right.
Backward?
Yeah, like I started with the higher, like I did it backwards. I did it flipped. I did it with
No.
the higher.
No. You start with the smallest data value. Yeah, you need to start with the smallest data value. All right, guys. So once you got your classes limits, now probably we can make our table. So step 4. So in our table, so we have classes boundaries, and then what else? We need the classes boundaries. It says midpoints. And then it says frequency, right? And then it says relative frequency, and then it says cumulative frequency. All right. So classes boundaries. So you subtract 0.5 or you add 0.5, subtract 0.5 from the lower limit and you add 0.5 to the upper limit. So lower limit 3, so then subtract 0.5, that's 2.5. So it's from
I'm sorry, Professor, I'm writing it down. You said from the lower limit, you.
Yes,
subtract-
yeah, sorry. Yeah. So you subtract 0.5 from the lower limit minus 0.5, and you're gonna add for the upper boundary, you're gonna add 0.5 plus 0.5 for the upper boundary.
Okay.
So you subtract 0.5 from 3, that's 2.8. So it's gonna be from 2.8 to, and then you're gonna add 0.5 to the upper limit. So that'll be your upper boundary. So that's 8.5. That's the first class. A second class, you subtract 0.5 from 9, so that's 8.5, and you add 0.5 to the upper limit, so that's 14.5 is going to be your upper boundary. So next class is 15, the lower limit. So we subtract 0.5 from 15. So that's 14.5. So it's from 14.5 to, and then you add 0.5 to 20. So that's 20.5. Next, subtract 0.5 from 21. That's 20.5. And you're gonna add 0.5 to 26. So that's 26.5. Subtract from 20.5 from 27, so that's 26.5, and you're gonna add 0.5 to 32, that's 32.5. All right, so yeah, so next, midpoint. Well, midpoint, guys, is just the average of your classes limits or classes boundaries is the same thing. So just to remind you here, the midpoint, the formula is just the average. That's the lower boundary or lower limit. It's up to you. You can use either boundaries or limits. Lower limit or lower boundary plus the upper limit or upper boundary over 2. Right. So, for example, for the first class, it's 2.5 plus, it's 2.5 plus 8.5. Right, over 2, over 2. So 2.5 plus 8.5, of course, that will be equal to 11. So that's 11 over 2. So that'll be the midpoint of my first class. So 11.2, of course, that's 5.5. Right, 11.2, that's 5.5. Next, guys, you can just add the width. You don't really have to apply again the formula. You can just add the width each time, plus 6, and plus 6. So that's 5.6 plus 6, that's 11.5, plus another 6, that's 17.5, another 6, that's 23.5, and another 6, that will be 29.5.
Excuse me.
Yes, please.
I'm a little confused. When how you know is +6?
The 6, that's the width, right? The width. The our width, we got 6.
Like the
So
other,
that's,
so like when
I
the
mean, you
width
get,
is 8, we just add +8.
well, yeah. If the width, let's say, yeah, of course.
Yeah.
If the width, let's say it's 8, then yeah, we're gonna add 8. Yeah, it depends on your width, of course.
Okay, so it's the width. Okay.
Oh,
Thank
yeah,
you.
yeah, sure. Yeah, it depends on the width. Yeah, of course, and the width depends on the problem. Yeah.
So you're doing 2.5 plus 8.5, right? And then.
Yeah,
11.
yeah, that's
get
11.
Yeah,
That's
you get
11
11.
over 2. Yeah, that's 11 over 2. That's how I got the 5. The first, the first midpoint. That's how I got the 5.5. But then after that, I just add the width, right?
Oh, okay.
Okay. All right. Now, next we need the frequency. So frequency, of course, you count how many, how many values are between the upper and the lower limit. So for example, first class is between 3 and 8. How many values are between 3 and 8? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think 10. We have 10 values between 3 and 8. Actually, I don't. I don't really have the answers, but so
I
you need to
have
check with you
10,
got 10. You got 10.
10, yeah. The following 9,
9.
number 3, 6,
Mhm.
class number 4, 2, and class number 5, 3.
Let me just check. For example, the third class, right? The third class is between 15 and 20, right? Between 15 and 20, the third class. So let me just make sure that your answer is correct, all right? Because I don't have the answers. So between 15 and 20, so we have 1, 2, 3, 4. You said the 6 between 15 and 20?
Yeah.
1, 2, 3, 4, 5. Did I miss something else? Okay, let me just, I'm sorry. 15 and 20, between 15 and 20. So we have,
There's
all
two
right, so we have
15.
15.
There's two
Then
of
there is
them.
17. Let me just go like, line by line. So you have
Okay.
15, 17, and then there is a 16, and then there's 20. Yeah, you're right. There's another 20, and there's 15. Yes, you're right. Thank you, Yanni. Sorry, but yes, you're right. Thank you. All right. So you got your frequency, guys. I guess I guess everyone knows how to get the frequency. So again, you just count how many values are between the lower and the upper limit, right? The lower and upper limit are included, right? So let me see the chat, make sure that there are no questions. Okay. All right.
You said
Relative frequency.
how many values are between
Say
the,
again.
you said how many
Oh, yeah.
values
Yep.
are
So
between?
let me write down the formula. So the frequency, that's just the number of data values. I mean, number of the values between lower and upper limits, boundaries. It's up to you. The same limits, right? Upper, lower, and upper included. Lower and upper limits are included. Okay, so that's what I mean by the frequency.
Okay.
All right, next, what else? The relative frequency, right? Relative frequency. So relative frequency, that's the frequency of the size divided by the size of the sample. So let me just write down the formula here. Relative frequency, that's the frequency of the class divided by the size of the sample. Okay. So like first class, it's 10. So it's 10 divided by 30 because we have 30 numbers. So the size of the sample here, guys, is 30, right? Just let me, so the size of the sample in this exercise or this example is 30 because we have 30 values. So relative frequency of the first class is 10 over 30. 10 divided by 30, that's 0.33. So relative frequency here is 0.33. So again, this is 10 divided by 30. Next, it's 9, right, divided by 30. So that'll be equal to 0.3. Okay. 6 divided by 30, right? So that would be equal to 0.20 or 0.2, right? 6, just 6 divided by 30. That's 1/5 actually. So that's 0.2. Now 2 divided by 30, right? So that would be equal to 0.08, I guess.
6.
Sorry, 6, not 8. Sorry. Thank you. And then 3 divided by 30, of course, that's 0.1. Okay. So again, just divide your frequency. Your frequency, for example, here 9 by the size of the sample, which is 30. All right, guys. Now, cumulative frequency. Cumulative frequency, just to remind you the formula for the cumulative frequency. That's the frequency of the, so cumulative frequency, that's the frequency of the class, frequency of the class, plus frequency of the class, plus frequencies of the previous classes, frequencies of the previous classes. So, so first class, the cumulative frequency of the first class is just because there is no previous class. So the cumulative frequency of the first class is just the same as the frequency of the class, right? Which is 10. Now, for the second class, the frequency of the second class is 9 plus the frequency of the previous classes, right? So the previous class is its frequency is 10, so that's 9 plus 10, that will be 19. Frequency of the cumulative frequency of the third.
Let me ask you a question, Professor, real
Yeah,
quick.
please.
So the second frequency, you're gonna add the first one to it?
Yes, you add the previous.
Always.
Yeah.
Alright.
Always you add previous frequencies of the previous classes. Yes. So like here for the third class, the frequency is 6 plus the frequency of the previous classes. So that's plus 9 plus 10. So it's like
Okay.
6 plus 9 plus 10. So the answer is 25. For the next, it's 2 plus frequencies of the previous classes. So that's 6, 9, and 10. So plus 6 plus 9 plus 10. So the answer is 27. And for the last class, that's the 3 plus the 2, 6, 9, and 10. 3 plus 2, 6, 9 plus 10. And so the answer, of course, is 30. Okay. And actually, the cumulative frequency of the last class is always equal to the size of the sample. If you have 30 data values, so that will be the cumulative frequency of the last class.
I was gonna say that's how I check if my
Yeah.
answer is wrong. Because if I don't have 30, like the number of samples I have, then there's a problem.
Yep. Yeah, Nina, absolutely right. Yeah, absolutely right.
You said the cumulative frequency can't be bigger than the size of the sample, right?
So what I'm saying is the cumulative frequency of the last class, it has to be equal to the size of the sample. Cumulative, let me write it down. Cumulative frequency of the last. It has to be equal to the size of the sample. Okay. So in B it says you need to draw the relative frequency histogram and OGI from the information in part A. So the relative frequency histogram, guys. So this is B, question B. All right, so we're gonna have 2 axes. So this is an histogram. So this histogram has to display the relative frequency. It's a relative frequency. Um, so we have so the x-axis, the horizontal axis, that's supposed to be our classes boundaries. Classes boundaries. So, and of course, there's this vertical, this is vertical axis. So in this case, just be careful. Here it says draw relative frequency histogram, right? So it has to display relative frequency. So that's why in the vertical axis, we're gonna plot the relative frequency. So again, it depends on the question, guys. Sometimes it's just the frequency. Sometimes it can be also a relative frequency. So in this example, this particular problem, it says a relative frequency. All right, so classes boundaries. So it goes from 2.5 to 30.5. So 2.5. So let's say this is, so we have 2.5, then 8.5. So, and then I think it's 14.5, 20.5, then 26.5, and then 32.5. Okay. Now, relative frequency, the values are between like the smallest value is like 0.06. This one is so relative frequency. The smallest value is 0.06, and the highest or largest value is 0.33. Okay, so we have 0.06, 0.1, 0.2, 0.3, and then 0.33. So let me just put the relative frequency here. So we have 0.06, then we're gonna need 0.1, we're gonna need 0.2, we're gonna need 0.3, and we're gonna need 0.33. Anyway, so relative frequency of the first class is 0.33. So first interval, this first interval from 2.5 to 8.5, that represents the first class, right? So the relative frequency of the first class is 0.33. So this is my 0.33. So this is, so this box here, or this rectangle, represent the relative frequency of the first class, right? So again, it's up to 0.33. Now, second class, it's 0.3. So second class, so it's represented by the second interval right here, and it goes to 0.3. So the height here is 0.3. Okay. Next, 0.3, then 0.2. 0.2, that's my third class, third interval. So 0.2 would be this right here. My fourth class, the frequency is 0.06. So 0.06 would be this right here. And my fifth class is actually 0.1. So it's a little bit higher than the previous class. So 0.01 would be somewhere right here, I guess. Okay. So that's the histogram of my relative frequency. Actually, you can describe. I don't. Well, it's not in the problem here. But if you wanna, you can describe the shape of the histogram, right? So the classes on the left side, they have like the highest relative frequencies, right? So like this histogram would be skewed to the left, right? Because the left side here, as you can see, has like the highest relative frequencies. Anyway, it's not in the problem. And so you have to draw the histogram and the ogive, right? So okay, I have like 2 minutes for the ogive. So I guess tomorrow I'm gonna go over the section. The chapter 3 and the 4. Right. Okay. So let me just finish with the ogive, guys, in a second. So ogive. So again, the ogive, the horizontal axis, again, we have the classes boundaries, 2.5, 8.5, 14.5, 20.5, 26.5, and 32.5, right? And the vertical axis, of course, it's the cumulative frequency in the ogive, cumulative frequency again. So we have, not again, but that's what we put in the ogive, right? The cumulative frequency in the vertical axis. So so the values are like 10, 19, 25, 27, and 30, right? So oops. So 20, 10. So here, let's say this is 10, 19, 25, 27, and 30. So the thing is, with the jive, the starting point is always the lower boundary of the first class. So we start at 2.5. Then next class, the relative frequency is 10. Sorry, cumulative frequency is 10. Next class, cumulative frequency is 19. Oops. So 19 for the next class, 25 for the third, 27 for the fourth, and last one is actually 30. All right, so then, so if you join the points, then that will be your ogive. So this is your ogive. All right. Okay, guys, I guess, so if any questions so far, let me see here, chat. Okay, no questions. All right, guys, I guess I'm gonna stop here for today. So this is the first part of the review. We did chapter 5 and chapter 2. So tomorrow, hopefully, we're gonna finish chapters 3 and 4. All right, thank you for listening, everyone, and I will see you tomorrow for the second
Yeah,
part.
is there a way
Yes.
I could speak with you? Like I could call you?
Yeah, we can talk. You wanna talk now after the lecture? Let me just first stop the recording.
Bye.
Sorry.
Have a good day.
Bye.
Bye. Have a good day.
Bye.
All right, thank you.
See you guys tomorrow. Take care, everyone. Let me just stop recording. Let me see.